Okay, so it's asking you to find the area between fx, gx, and the x-axis, and you know that fx and gx are the above functions of the problem, because one, it says it bounded above, and if you graph it, you can just see it here. So here is your fx function, which is x squared plus 10x plus 25, and then your g function, negative 2x minus 2, is this blue one here, and you're asked to find the area between, which is basically finding the area of two triangles that are above the x-axis and below the f and g functions. You're given these restraints, so -5 and -1, which are these black bars here. So this is just a visualization. On the exam, I don't think you will be able to use this graphing like function. I'm going to explain how to find the intersection, which is -3 here, before I continue anything else, because that's important. Maybe I should I hold it like this the entire, okay, whatever. So if you need to find the intersect, because that's your third very important value, you set the two functions, so fx and gx, to each other, and you solve for x basically, and you'll get -9 and -3 in this situation. You can't use -9 because -9 is way over here and it's not relevant to what we're doing, so we're going to use -3 because that's this intersection. And with that, you now have your b and a values for the two different parts that you have to do. Basically, you have two parts because you're doing the area of two triangles and adding them together. So your first triangle is the fx function constraint above triangle, which is from -5 to -3. So your a and b are going to be -5 and -3. If you ever get confused on like which value to use for a or b, basically b is going to be your bigger value, which I remember because b big. So like if you had -7 and +8, 8 will be your b because it's bigger. And then if you had -1 and -20, -1 would be your b because it's bigger. And I like to separate it into two like separate problems, and then I add them together later in the calculator, but you can add them all together as long as you use the absolute value bars. And before you plug in your a and b values, you need the antiderivative to plug it in. So to find the antiderivative, you just take your original function and like do a reverse derivative. So in this example, you'll take x squared and you'll make it 1/3 x to the third, because the power rule, which is basically whatever power you had before, you go up 1, so 3, and then you add a fraction of it divided by the denominator being the new power. So if you had x to the 5th, it would be 1/6 x to the 6th, and if you had like a number in front of this, so technically speaking there's a 1 here, which is why this is 1/3, but if you had 10 in front of it, like this one, you would divide that number, and then that's why I have a 5 down here, because 10 divided by 2 is 5. And yeah, so you just take your f function here, your g function there, and you plug it into your calculator, and I got 20/3 for my area. And on the calculator, the absolute value bars are like very important because I always mess up when I don't put them in there. And to get that, you go to math, you go over to number, and it's the first one. Boop. And yeah. And if you ever need to use a graph to visualize it on the exam, I don't think you're allowed to, but if you don't know how to do this part, which is where I usually get stuck, you go to y, you can just plug it in, then you go to second trace 5, and you can find the intersect with this. Okay. Very complicated mansplaining math video.